So for this reason, 0 factorial must be 1. Each ordered definition of 0 factorial would not be in line with the pattern we have just seen. So we were always taught in school that 0 factorial equals 1. And now we would like to explain why this really makes sense. So just as a recap, a short definition of factorial: for n, a natural number bigger or equal than 1, n factorial equals n times n minus 1 times n minus 2, and we are repeating this process until we arrive at 2 times 1. So we are just taking the product of n with all subsequent lower numbers. So as an example, 3 factorial is 3 times 2 times 1, which is 6. Or 4 factorial is 4 times 3 times 2 times 1, which is 24. So for natural numbers this really makes sense, but for 0 we cannot follow this process, because for 0 factorial we cannot just take all the natural numbers between 0 and 1 and then multiply them, as we have done it before. We have done it from the given number and have multiplied all the numbers until we arrive at 1. We cannot do this. So why 0 factorial should not be 0, for example? So this is not true, so I will just cross it. It's 1, so 0 factorial is 1, but let me give you a reasoning why this is the case. The following also holds true, so n factorial is actually also the same as n times n minus 1 factorial. This is exactly the same, because also here on the right hand side we have all the factors between n and 1. N is here, and here within n minus 1 factorial we are taking all the factors between n minus 1 and 1. And you can also see it here inside our example. We have 4 factorial here, but inside 4 factorial we have 4 times 3 factorial. 3 factorial is exactly 3 times 2 times 1, what you have seen here in the first example. So this equality is true, indeed true. And now let's insert n equals 1 here. What are we getting then in that case? We are having 1 factorial on the left hand side equals 1 times 1 minus 1 factorial. And this is equivalent to 1 factorial on the left hand side still equals, we can just leave out the multiplication with 1. So this equals 0 factorial actually on the right hand side, because we are having here 1 minus 1 factorial. And this is again equivalent to 0 factorial equals to 1. So there you have it. 0 factorial equals to 1 according to this general principle of factorials. So this is one reasoning, and if this is enough to you, you can just exit the video. I will give you another reasoning why the definition of 0 factorial being 1 makes sense. So the second reason is the following. For a set, let's call it S3, consisting of the numbers 1, 2 and 3, we could look at the number of possibilities we can order this set. So one possibility would be 1, 2, 3, another one would be 3, 2, 1. How about 3, 1, 2, and so on. And the number of possibilities you have for this given set is actually 3 factorial. And just in general, for Sn, where you have the set from 1 to n, one can prove that the number of ordering you have is n factorial. So we have n factorial possibilities. For the ordering. And now we could ask ourselves, what about S0? So S0 would then consist of the empty set. And there, actually, the number of ordering is also 1, just being the empty set. Yeah, so just leave the empty set as it is. So this is the only ordering you would have, and this means it's also one possibility. So if this is too abstract for you, I will make in the future a video about the second aspect. For now, the first reasoning should be enough for you to understand why 0 factorial equals to 1 makes sense. And for the second reasoning, I will provide a video very soon. If this is interesting for you, please leave a comment, subscribe to the channel, like the video, and also stay tuned for the next video I will post about exactly this topic if this is interesting to you. Until then, see you and have a nice day. Bye bye.